What is post-buckling behavior in structural buckling design? Imagine a tall, slender column standing under heavy weight. It suddenly starts to bend and shift, yet it doesn't collapse right away. That's what post-buckling behavior is all about. When a structure like a column or shell experiences buckling, it means it's lost its stability and begins to deform sideways. But instead of breaking immediately, it can continue to carry some load even after buckling has started. This phase is called the post-buckling phase. Understanding what happens after buckling is key for engineers. Some structures can handle more load after buckling without falling apart. This is called stable post-buckling. It's like a bridge that bends a little but stays strong enough to hold traffic. Other times, post-buckling leads to quick failure. This is unstable post-buckling, where the structure suddenly collapses. Think of a brittle shell that cracks and crumbles once it buckles. The way a structure behaves after buckling depends on many things. Material type matters. Ductile materials like steel can often deform more gradually. Geometry is also important. A well-designed shape can support more load after buckling. Boundary conditions, or how the structure is held in place, affect stability too. Load distribution plays a role as well. Uniformly loaded structures tend to behave differently than those with concentrated loads. Designing against buckling involves understanding post-buckling behavior. Engineers analyze how structures will respond if they start to buckle. They look at whether the structure can carry additional load without failing. This helps decide where to add reinforcement or change the shape to improve safety margins. For example, in aerospace, where weight and strength are critical, knowing how parts behave after buckling helps prevent catastrophic failure. In bridges or storage racks, understanding post-buckling guides how thick or stiff the material should be. It also influences choices about cross-sectional shapes and support placements. The goal is to make sure that if buckling occurs, the structure either remains stable or fails in a controlled way. This way, engineers can design safer, more reliable structures that stand up to extreme conditions. So, post-buckling behavior is about what happens after the initial instability. It shows how a structure deforms and whether it can keep carrying load or if it will suddenly give way. Recognizing this phase helps prevent unexpected failures and keeps our buildings, bridges, and machines safe and functional.